Hey guys, so if you saw my video the other day, you'll know that this is actually operational now. Still very bodgily though. As you can see, I've got a RC tar transmitter here as my throttle, just taped on, and the brake switch lockout's not connected and all that sort of stuff. I ordered a thumb throttle from China on the 13th of December, and well, it's almost been a month now and it's still not here, so not too impressed about that, but this works for now. Of course, this has no throttle limiting at all, so if you smash the throttle on this, it goes to full throttle, so it's not really something that you can sort of let other people use unless they know, sort of the issues with running brushless motors like this. Those issues being, well, because this is a 245 kV motor, it's quite inefficient at low speeds. So if you're only just rolling sort of thing, or not moving at all, and you try and smash the throttle up, the motor will just cog and it'll draw like insane amounts of current. So you sort of have to be careful of that kind of thing. Eventually what I'll do is, because I'll have a reed switch on this that'll be determining the speed, I can use the microcontroller to sort of limit the throttles to certain amounts for certain speeds. Sorry about the sniffling. But I've also got a 168 kV motor on the way, so that should help with lower speed efficiency as well. So, and it also has 2 more poles, and it's about 1 centimeter longer. So yeah, that should instantly give me about 20% more torque at lower speeds. So that'll be good. So I'll try that out. Apart from that, there's not really much going on in here at the moment. I'm still working on my circuit board, so this is just a little cell monitor thing that I've taped on here to, if I can plug it in. Okay. So yeah, that's just how I can monitor the batteries without having to open the thing up, because that was a pain. And if you look in here, take that off. Yeah, so basically all I've got in here is just a paralleling adapter for the batteries. This is the balance plugs. They've just been paralleled, and another wire runs up here for this so I can monitor them. Yeah, I've left that open just because it adds a little bit more airflow through here, so I'll probably have a fan in here eventually. These are the motor wires. Yeah, this is actually 12 gauge, but it's way too thin. I need something like this 10 gauge here, because this gets really hot. Yeah, I've patted down the LiPo batteries so they don't bash around. So yeah, that's good. They don't even get warm in use, so I'll probably add a third one as well. So yeah, these things aren't even being run near their discharge capabilities already, just with 2. So yeah, they're good. Yesterday I actually added a fan. So this is just an LM317, and because this is sort of an angle bracket, it already sort of forms a box around the motor. So what I did, lay this over, so just taped and glued up like a temporary cardboard shroud sort of thing, and I don't really see it, but there's a fan in there, and what that does is it sucks air in through the back here, and then tries to suck air in through the windings through the motor as well. So that's sort of what that's aiming for, but it also cools down the outside and the magnets as well, because the limitation with these brushless motors is mainly the magnets. If the magnets get too hot, they lose magnetism and the motor just becomes mega inefficient, and eventually it just stops working altogether. So yeah, cools the magnets down really well. The windings still get pretty hot, but they're rated for a couple 100 degrees anyway, so it's not too bad. So yeah, eventually I'll probably cut up a proper acrylic box to do this, and that's just a high flow, I think it's a Jamicon or something, 80mm fan. That's actually out of my laser projector there, because it's the highest flow 80mm fan I've got. So yeah, So that's being run off that LM317 that's set to 12 volts, or probably slightly over actually, but yeah, running off those batteries. So that's heat sinked onto here. Annoyingly, it's really inefficient, LM317s, linear regulators, so what I'll probably do is put another fan in here and just series these two together, and then that way I can just run them straight off 24 volts through the power switch, so I don't need any regulators or anything. So I'll see about doing that. I'll also probably install a little temperature sensor in the motor and also in here just to monitor everything nicely. Apart from that, this is what I've got on the circuit now. Originally I was going to use like a full-on battery management chip, but with the way that works, I ended up, there was actually two different ground potentials, so that was a bit of a pain in the ass to work with. So what I've done is I'm using a LTC6803-4 from Linear Tech, and this is just a cell monitor basically, so you've got all your cells running in here. Yeah, all the balance connectors, and the good thing about this is there's no high current running through this board at all. So yeah, I don't need any high current traces or fuses or anything like that. So yeah, apart from that, just a basic microcontroller there, 80 mega, 328, and that's an RJ45 jack. That'll actually go up to the control panel on the handlebars, so that has the two serial UART lines, and that'll run on the handlebars. There'll be a separate microcontroller that'll drive like an LCD and stuff, and that'll communicate with this one through serial, so that's what that's for. And also I'll run all the throttle and brake signals into that one and just run them all down the same Cat5 lead, so that's sort of a handy way to do it. And I can also run, you know, a 12 and 24 volts up there as well, auxiliary power. So yeah, I think this is basically done. I've just got to put it on a PCB now. So you've still got the 12 volt auxiliary power out there, you know, and all that fun stuff. So I'll be using an external shunt now. So I've got this little ADC up here, just a single channel, I think it's 16-bit differential. So yeah, that way I don't have to run any high current through the PCB at all. So that makes it a bit easier, and I can fit it on a smaller board also, because originally I was planning to put the board on top of the batteries, but as you can see there's like a bar there, and if you step on that too much it sort of bends inwards, and well, you'd kind of crush the circuit board and it'd be poking into the batteries and stuff, so that'd be kind of, you know, a bad thing. So I'm intending on trying to fit it down sort of inside beside the ESC or something like that, because that'd work a lot better. But yeah, apart from that, just been mucking around with that basically and designing the circuit. Yeah, so hopefully I'll get my throttle soon and I can do up the proper microcontroller control with ramp up and try in the new lower speed motor and see if that keeps it a bit cooler and happier. So yeah, that's all good, just something to work on I suppose. About the 8th revision of this circuit, but it's all fun stuff, you learn more and more. Anyway, thanks for watching, and I'll do another video when I install the new motor or something like that. Alright, thanks.